Hi everyone, today I want to talk about the type of the spatial analysis in GIS. There are four types of the analysis which are measurement analysis, cluster analysis, overlay analysis, and network analysis. The first type of the analysis is measurement analysis. Measurements are simple numerical values that describe aspects of geographic data, including distance, perimeter, and area. For distance, there are many ways to measure distance, like most GIS programs have a ruler button that allows you to measure distance across a map. Many vector-based systems measure distance along axis vector line networks like straight, silver, and railroad. The distance will be shown in a GIS when you point on the map where you want to begin your distance measurement and then click the ending point. This is the sixth type of the distance measurement, and the figure shows the measurement between pairs of objects. Next, the perimeter and area. Many vector systems automatically generate area and perimeter measurement for polygon feature and store this value in prescribed attribute field. Basically, measurement of the area and perimeter is about the measure of the polygon. So, how do we measure area of a polygon? The measurement is processed in clockwise direction around the polygon. The second analysis is clustering analysis. Cluster analysis is the classification of a set observation into subset. It is also called that cluster, so that the observations in the same cluster are similar in some sense. Cluster analysis given a set of wave features, identity statistically significant hotspot, cold spot, and spatial outlier. Clustering lets you view the geographic density of points or events, showing grouping of high or low value that stand out in your data. For example, in the big picture, by analyzing how many people live within a 15-minute drive time from existing store, a retailer can predict and determine the best possible location for a new shop. For another map telling about the hotspot analysis, that about alcohol abuse mortality rate within the United States. Through the cluster analysis, we can know that how the rate of an area about the mortality. On the other hand, color, line, and shape can help us more easily make sense of data. Overlay analysis is a third type of the analysis. Overlay analysis is one of spatial GIS operation. Overlay analysis integrates spatial data with attribute data. Overlay analysis does this by combining information from one GIS layer with another GIS layer to derive or infer an attribute for one of layers. Tools are available in most GIS software for overlaying both vector or raster data. Next, the vector overlay operation. There are 7 types of the operation, which are the first one, union. Union is the sum of the two layers. The second is intersect. Intersect is the area we capture from the overlap of the two layers. And the third one is symmetrical differences. This is opposite from the intersect. The area captured is except from the overlap of the two layers. And the fourth, identity. Identity is the extent of one of two layers with a geometry and attribute merged in the area where they overlap. And the fifth one is clip. Clip is also called that cookie cutter. And erase. Erase is the opposite of the clip. And the last one is a split. Split is about to divide an input layer into two or more independent layers. Besides, the raster overlay operation, which is also grid operation. The raster overlay involves two or more different sets of data that derive from a common grid. The separate set of data are usually given numerical value. These values then they are mathematically merged together to create a new set of values for a single output layer. Raster overlay is often used to create risk surface, sustainability assessment, value assessment, and other procedures. This is the overview of the map overlay function in GIS. The combining of the layer to create a vision complete map for the customer to consume it. So this is make the consumer more understand in the visual data when they show. And the last one is network analysis. Network analysis involves analyzing the flow of networks, which is a connected set of line and point nodes. This linear network most often represent features such as river transportation corridor, like routes, railroad, and even flight paths, and the utilities like electric, telephone, television, silver, water, and gas. Point nodes usually represent pickup or destination site, client, transformer, valve, and intersection. People, water, customer package, kilowatt, and many other resources flow to and from nodes along linear feature. Network analysis gives convenience to the user, which help you analyze the cost of moving through the network. It can save your time and money. Network analysts can find the best way to get from one location to another, or to visit several locations. The best route can be the quickest, shortest, or most scenic route, depending on the impedance chosen. If the impedance is the time, then the best route is the quickest route. Hence, the best route can be defined as the route that has the lowest impedance, where the impedance is chosen by the user. Next, the closed-set facility. The closed-set facility solver finds the cost of traveling between incident and facility and determine which are nearest to the other. For example, finding the closest hospital to an accident, the closest police car to a crime scene, and the closest store to a customer address. The last, surface area analysis generate polygon or line that cover all edges within a given distance, travel time, or other impedance unit from the predefined facility. A neighbor service area is a region that encompasses all accessible streets. Service area created by neighbor analysis also help evaluate its accessibility. Concentric service area show how accessibility varies with impedance. Once service areas are created, you can use them to define how much land, how many people, or how much of anything else is within the neighborhood.